Ace Podcast.
Hello, hello, hello. This is Jonas from the Crazy Town Podcast. You are listening to Vaguely Accurate on the Ace Podcast Network.
What's up, everybody? Welcome back to Vaguely Accurate. I'm your host DK, and today we're going to be meeting Pieter. He is a computational engineer, and we're going to be discussing such things as driverless cars, artificial intelligence, and pretty much find out that Skynet is almost here, but we shouldn't necessarily be afraid of it. Pieter's going to do his own introductions, but before we get into that, I would just like to apologize for our lack of activity over the past couple of weeks. I have been incredibly busy. First of all, if you haven't noticed already, we have a new website for vaguelyaccurate.com. Please check it out. I'm awfully proud of it. I designed it myself. Tell us what you think. Find us on Facebook or Twitter. Tell us if you enjoyed it or if you find any bugs. That's a big help as well. We also have a new division and new website for acepodcastnetwork.com. I was asked to design them a website, so please, again, check it out at acepodcast.com. I want to find out if you guys find it practical, if you guys find it helpful. After all, we're a mutually beneficial community and it's there for you guys. So if it's not working, then please tell us. The last announcement I have is that Ace Podcast is now launching its second division, other than the entertainment division you're currently aware of, as Ace Knowledge Podcasting. This is a division whereby we're encouraging the collaboration and networking of science communication and knowledge professionals. So if you're a scientist, a researcher, a science communicator, or just a science enthusiast and hobbyist, get in touch with them if you have an idea for a podcast show and want to get involved on the network. So I'm not going to talk too much longer today, guys, but I really hope you enjoy the show and stay in touch. Introducing yourself and telling us a little bit about your field and what it means to you.
Yeah, so my name's Pieter, and I guess I work in self-driving cars for Mercedes. Really, it's a branch of AI, so really what I work in is AI. I guess about myself, I originally worked in mining here in Perth, and I could see the
slump.
Yeah, maybe that the future wasn't so bright, you would say. And I was a control systems engineer, so I did industrial programming, and I did, like, AI is a bright new field now, so I decided to move to Toronto in Canada, and I did a master's degree there at the University of Toronto. I guess my study focuses, what I've really gotten into now is artificial intelligence.
Mm-hmm.
Yeah.
So what made you do a master's degree in Toronto rather than your home country? Or
originally my plan was to move to North America, specifically probably Silicon Valley or something, and jump on the whole tech bandwagon. So The thing is, with a degree, you should really try and do it in the area you're looking to work. Because no one knows about the University of Toronto here, but in America it's a very respected university.
Okay.
So, and likewise about the big European institutions.
Yeah. So when you did your master's, you went to a master's, right?
Yep.
What were you doing before that?
So before then I was working here for Rio Tinto as a control systems engineer. So I worked on some of the big port projects they had here.
So you've always stuck in the field of engineering all the way through?
Yeah, I've always been an engineer.
More of the electronic kind of tech side. How would you define your field of engineering?
Originally I've actually had quite a few roles, I would say. Like, my first job was actually in oil and gas as a mechanical engineer.
Mm-hmm.
But I've progressively moved further towards software, because really I think that's where the future lies.
Couldn't agree more. If anything, any form of engineering, yes, you still need the mechanical interface in some respects, but software engineering, coding and developing programs seems to be the way forward.
Yeah, that's really the be all and end all at the moment. So it's been an interesting field, definitely.
So what did you do for your masters? Are you able to tell us a little bit about what you were actually looking into in your research project?
Yeah, so first of all, the masters I did was more coursework based, but I did do definitely some research. I guess just about the University of Toronto. They're generally quite a well-regarded institution, especially for computer science. They're generally regarded as one of the top 5 or 10 in the world. So they've done a lot of work in the field, and one of the I mean, I don't know, in my opinion, I would call this the invention of the century, but
it's a big claim.
Yeah, it is. It definitely is. So basically, they developed this new kind of artificial intelligence that's based on the human brain.
Okay,
so
a consciousness. Are they claiming they've made?
No, not something like that. I mean, well, yeah, we can talk about that later, but basically, it's a new kind of AI algorithm that's based loosely on the human brain.
That's really interesting.
Yeah, it is.
And I haven't actually seen a lot in media about that either.
There is a lot out there. It's called deep learning.
Deep learning, okay.
Yeah, so it's just one of those catchphrases people use, but really what it is a computer algorithm that's based on the human brain.
So what makes it, in your words, the invention of the century?
Because it just works so much better than anything else out there. So probably the main use case of this new algorithm is Google search. Mm-hmm. So Google search is that's probably the biggest, most famous, biggest money-making algorithm in the world, right? I mean, that's where Google gets all their money from.
Incredibly,
right?
Yeah.
Yeah. So that's traditionally been a kind of like a rule-based system. So they've got a whole office full of PhD people, coding all these rules and tweaking and they've been doing that for 15 years or something now?
Quite labour intensive as it goes.
Yeah, and we're talking about a team of hundreds of people. Now, with this new technology, deep learning, within 6 months, a team of, I think it was 5 or 6 people were able to produce something that already worked significantly better than this system that the Google engineers have been working on for 15 years.
As amazing as that sounds, yay for more unemployment.
Yeah, I mean, that's definitely also one of the things that will result in, but probably, I mean, this algorithm's around us everywhere. So now when you type into Google search, it's using this new algorithm. Also, the voice recognition on your phone, that's this new algorithm, and also image recognition is also done using this new algorithm. And they've been able to get human or better levels of performance in terms of recognizing images.
So would you say that it's passed the Turing test?
No, that's, I would say, a different case again. Okay. And but that's definitely a very good question. At the moment, really what this algorithm is good at is classification. So, if you show it apples and oranges, deciding between an apple and an orange, right?
Yeah.
But that true, real intuitiveness, which I would say is what AI really is, that's still quite a few years away, I would say.
When you were studying at university, I assume, did you learn to code in your undergrad or postgrad? And when you learned to code, how did you find that transition into a new language, and what software programming language did you use?
Yeah, that's a really good question. So I did physics, maths and mechatronics for my undergraduate. So I did 2 degrees. So I learned a bit of programming in physics, and I did 1 or 2 units as part of mechatronics. But yeah, I was never really a properly trained programmer. I knew what the basics, but I mean, a computer science student, they have a lot more knowledge.
They've got a huge library of tools.
Yeah, and they're really also taught those concepts of how to write a good program. For me, that's something I've just picked up through jobs and through learning off other engineers.
Okay.
Yeah, and even then, I would not say I'm really a very strong programmer. Really what I do, what my strong point is maths.
Yep.
So, from my physics and maths background, I have more kind of knowledge, I would say, in that field than someone who's just on computer science.
Which is still important, especially when it comes to designing algorithms and stuff like that. That's where the true talent's going to come from, not knowing just how to write it, but you also need how to work it. It's like knowing how to speak English, but it doesn't work unless you can do the math to translate it.
Yeah, that's exactly right. And I mean, the way I look at a computer is really as a big calculator, right? To run an algorithm very powerfully. Yeah. So that's as opposed to something to make a big software program or something with.
So this is a bit of a segue question, but a lot of people say that I'm going to try and word this right. Maths is a tool to be used by the other sciences, right? That's quite a common phrase that I've heard. And you've just said that you use maths, which is defined as a tool, in computing, which is also a tool. So would you say with the development of AI and algorithm development, is math becoming less of a tool and more of its own science?
That's something I have to think about. You're definitely right in that all the other disciplines will use maths, right? Engineering, physics, whatever, right? But there is maths as a study and a science in itself, like, what you would call pure mathematics. Stuff like rings and groups and all kinds of, like manifolds, like those kind of pure maths kind of constructs.
Yeah.
And those, addition, multiplication, calculus, yeah, sure, that's used, but like these pure maths concepts aren't used by other fields.
Okay.
That is used a little bit, you're right, in terms of AI. So some of these more advanced kind of maths constructs are starting to come out, but pure maths is still very much its own field, I think. That's an area of research. And whilst maths is, I think, a very important skill to have, and it's very widely used, I think that kind of pure maths research is probably actually a neglected field these days.
Yeah. Okay. I really want to get into the driverless cars and AI conversation, but I'd like to just backpedal one little step. And could you just tell us, as a summary of the research you did and your master's degree, what did you do? What did you find out? And just conclude it nicely for us.
Yep. Okay. So basically, the main thing I did was focusing on speech recognition. So coming back to this whiz-bang algorithm I was talking about, I was lucky enough to be able to do a project in the lab which first brought it to speech recognition. That happened in 2009. That's what you would call probably the first real kind of practical application of this technology.
Yep.
So what I did was basically focusing on recognizing difficult words. So basically, you think about the English language as something that has maybe 30,000 words and stuff, or something, and we're constantly making and inventing new words, right? First of all, you've got all these tech names like Twitter, Facebook,
YOLO.
Yeah. So there's all these new words, and then of course there's also the difficult words like hippopotamus, right? How often does that come up in conversation? And also, not often, unless you're in the field of like zoology or something like that. Yeah. So, words like as or well or it's, we use them every 5 seconds, right? So they're quite easy to recognize, But, these very long and rare words, they're much more difficult, right? Because, they come up so much more frequently. So basically my work, I was part of a project that revolved around basically collecting more data surrounding these hard to recognize words. And it was done basically as a matter of crowdsourcing. So we got 100 speakers to backpedal, we found 100 of these hard to recognize words based on the performance of a previous system. And then we crowdsourced 100 speakers to say all these words, and therefore, build up some more data of what these words actually sound like. And then we did some recognition of these words.
How did that come about? Did you find that I suppose you were using the data from what you found to put input into the software to make a permanent change, to make the software more recognizable of those words? Did it work?
Yes, we did get some improvements. So interestingly, one of the main problems was we were using a system that was built to recognize American English speakers, and all the 100 speakers were German, so they were speaking English with a German accent. That gave the system quite a bit of difficulty. But basically what we were after was the breakdown of these words. So, something like hippopotamus or all these words can be broken down into a number of basic speech building blocks called phonemes.
Okay.
So there's 43 of these different sounds. So it's like k, it, or
So is that like the overarching category of syllables?
Yeah, pretty much. Yeah. So basically really what the task is to break down these big words into their corresponding string of like sounds, which is really what these speech recognition systems recognize. And then there's another algorithm which will come through and join them all together.
How do they? Sorry, go.
Oh yeah, sorry. And these are two separate steps.
How do they actually cope with accents? I've always wondered how they
with great difficulty.
Yeah.
Yeah. So I mean, just to take a step back, the way all these AI algorithms work is, you know, traditionally a computer program is a bunch of engineers or whatever sitting down and programming everything by hand, right? And really what AI is about is, instead of doing all this programming with people, what you do is you collect a whole bunch of different examples and then show it to the algorithm, then the algorithm will learn by itself how to you know, train, or how to discriminate. So, you know, if you were to have a sorting machine between apples and oranges, right? You know, previously you would have an engineer who would code up what an apple looks like. You know, it's green and an orange is red, right? So when it's, sorry, orange. So, yeah.
Wasn't going to highlight that one.
Yeah. So, you know, you would code something to say, if it's orange, put it there. If it's green, put it there.
Yeah.
But with these AI algorithms, really what you're doing is you would show it 1,000 examples of each, right?
Yeah.
And then you would go work it out. And then it learns itself that an orange is orange and an apple is green.
So an AI, for simplistically put, an AI is a piece of software that has been given the tools to learn.
Yeah. Yeah, so something really, it builds a model itself about the task you're trying to do. So I guess, yeah, just bringing this back to the question about accents is, this is really where all these algorithms fall over at the moment. So if you have apples and oranges and suddenly you show it a pear, it doesn't know what to do, right? So I think you could really argue that this whole name AI at the moment is a misnomer. Like, everyone's getting really worried about, you know...
I was going to ask you about that kind of whole, not conspiracy, but like dystopian kind of phenomena that people tend to conjured up from that AI.
Yeah, the reality is the current algorithms we have, they're not AI. Really, what they should be called is pattern recognition. And when you show it a pattern that it hasn't seen before, namely like a pear or something, it really doesn't know what to do. So that kind of intuitive step to say, oh, it tastes like an apple or something like that, you know, these algorithms just break apart. And it's the same thing with accents. So, yeah, and this is also why our system struggled with German speakers, is it hadn't heard Germans before. So what does it know what to do, right? So the reality is, what they do in practice, like these big companies like Google, is they'll get thousands of people from all over the world to you know, speak and record data to show this system, right?
Yeah.
And this has made it out into the real world as well. Like Google, with their speech recognition system, it never used to work very well with Australian English, with our accent. You know, for Americans it was great, but because they'd never shown it Australian speakers before, it didn't know what to do.
Yeah.
I mean, I think they fixed that in the last year or so, but
that's fascinating.
It's definitely something that,
there's
just
not
like
huge differences. There's the Australian twang that's quite common and stuff like that, but there's not significant differences all the time. Even some of the words you use are very, very common.
Yeah, and that is one of the downfalls of this deep learning algorithm, is that it's very specific, so it needs to see something quite similar to what it's already seen before. And for a company like Google, that's not a problem, because, you know, they'll hire 1,000 people all across the world and, you know, each get them to spend a year recording speech or something, right? So, I mean, for them, they can actually do that. I mean, sure, it costs a bit of money, but it works, right?
And Google are not exactly sure.
Yeah, but, you know, that's a lot of the problems that face startups, is just they haven't got millions of dollars to build these kind of training sets.
Now, I want to ask, you mentioned that you've got it shouldn't really be called AI these days at the moment anyway. It should be called pattern recognition. Are there any systems out there that AI could be more of an appropriate term for?
That's a good question. So, one of the big recent advances, I mean, this is, as a field, is progressing very quickly now, but one of the biggest things in the news in the last couple of years was the AlphaGo victory of Google. So Google is by and large the leader in this field, primarily, or, you know, in part due to the fact that they just hired everyone from the University of Toronto. But so this AlphaGo thing was this computer that played the game called Go.
Okay.
Yeah, and Go is
the Japanese
Go?
I think or is it Chinese?
The competition was in Korea. That's all I know.
Okay, maybe it's Korean.
Yeah, but but for computers, it's a very hard game to play. And this game was able to beat the world. Sorry, this computer was able to beat the world champion.
I think I heard about this. Like, I think it was just a headline that popped up on my screen. It was like, world champion Go player beaten by AI or something.
So that's something where you could probably argue that's a bit more towards AI, as in being able to intuitively make steps. There's another new technology that's come out in the last year as well called generative adversarial networks.
Okay.
They're related to deep learning, but they're a bit different. And to be honest, I don't know too much about them, but they're also definitely making waves. So
So with AI, like, we're going to move into kind of your field at the moment now. So you're working with driverless cars. It'll be a good question to ask, where is the field of driverless cars heading, and can we expect to see driverless cars anytime soon? Like, when I imagine a driverless car, I'm thinking iRobot. Like that kind of pod that you just sit in and it just takes you. That's what I've got in my envision. What's actually being done?
Yeah, that's a really good question. To be honest, I think when these things are really going to be out on the road is anyone's guess at the moment, which is a very interesting situation because each of the big car manufacturers has invested $1 billion each into this technology, into research, and no one knows if it's going to work, when it's going to work. I mean, especially Tesla and these companies are all predicting in 2 or 3 years, but the reality is nobody knows. Really what the problem is the laws which will allow these things on the road. And they don't exist yet.
No, that's kind of a boundary that can only be looked at once they're available, I suppose, because they need to be able to understand what functions it works by, how it operates, and stuff like that. I mean, running over people at zebra crossings isn't going to be a great thing for a car to be doing.
But in saying that, there has been some very good progress. I mean, really what you've got to keep in mind is the real world is an incredibly complicated place, right? So Google really kicked all this stuff off. That's really why everyone's looking at it now, is because Google started doing it. And I think they're probably, I mean, given they've been doing it the longest, they're probably the most advanced at the moment. And their system has got some very impressive performance statistics. So, driving along something like a highway is quite easy, right? I mean, rarely ever something comes in front of the car. Really, you just need to keep separation, right? Driving down a busy street, you've got pedestrians ducking behind cars and stuff. That's much more difficult. And then, I mean, Google recently also presented on some of the issues they've faced. I mean, there's all these different situations out in the real world, like they've had people running naked in front of their cars and stuff, right? Like, there's all these things you just can't predict or simulate or plan for, right? So, getting something that could really, cross all of these different situations, we'll see how we go with that.
That's really, so I'm just trying to imagine it between the differences between what you mentioned before, AI and pattern recognition. You can add a lot of sensors onto a body of a vehicle and then assume it picks up any movement within a small vicinity. It will slow down, for example, or something like that. Whereas AI would be able to distinguish what exactly that movement is and then identify the correct response it should take.
And Google's system does do that. It is able to detect the pose of a pedestrian and work out if they're going to cross the road in front of the car or not.
That's pretty impressive.
So they have actually got quite far, but a system that's really legally safe to drive along the road without you being in charge. I mean, the reality is nobody knows. People will predict or say or whatever, but really nobody knows.
Do you have any particular thoughts yourself on the whole idea of a driverless car?
I mean, for me, I definitely think I can say where I think the technology is, but really what I think it's going to come down to is public perception and the laws and the regulations, and it's anyone's guess as to what happens there. So, I mean, there's already safety rated computer systems out there, computer systems that if they fail will kill someone, right? Traffic lights being a good example. planes being another. They're fully controlled by computers these days.
Yeah.
And there's very stringent safety regulations about how they operate. These cars, I would say, are not near achieving this kind of level of rigor. So I don't know, what we're already seeing in the US is the big car companies and Google are starting to pressure regulators to allow these cars on the road.
Okay.
But, from a statistical point of view, which I think really is the way we should be looking at these things. These cars are already way safer than human drivers.
Oh, I mean, you're never going to get an issue with drunk drivers or just the reckless drivers and like the ute that always cuts everyone up on the freeway.
Yeah.
Whoever drives that single ute that's always on the freeway, I'm pretty sure it's his job.
Yeah.
But I mean, it will eliminate all those hazards in itself. The only issue would be individual and server failure, I suppose. Would they run from a server?
No, it'll all run locally on the car itself, but it will have a connection to a central server to get map data. So basically the way these cars generally work is a two-tiered system. So the first is route following, and what they're doing is they're making like we have Google Maps now, right, which can already tell where all the roads are.
Yeah.
Now a lot of these companies are going out and making very detailed maps of the road, so the car will know to within 10 or 20 centimeters where to drive.
I'm incredibly impressed recently where, I don't know if it's all Google Maps or just the Australian one recently, but it'll actually tell you the exact lane you're meant to be in now. It'll be like, take the second lane from the left and then turn right. And you'll be like, oh, okay, thanks.
Yeah, so they're all busy building these very high precision maps. So that's one thing, probably one aspect of this technology is that, the car is just following tracks which have been pre-recorded with a human driver.
Yeah.
And there's no AI in that. There's no intelligence. It's just, I want to get from A to B. I follow this track that someone's already drawn out for me. The AI comes into the collision avoidance and pedestrian detection. So that's kind of like the second tier. So you can already say on something like a highway where there's pretty much never something in front of you.
Yeah.
It's just distant keeping of other traffic that, that's quite easy to do.
That almost sounds just like a more advanced version of cruise control. Just distance keeping between other people and keeping speed.
And some of these companies are actually billing it as advanced cruise control.
Okay, that changes the name of AI, which may get rid of some of that controversial stigma that's often associated. And Hollywood likes to, I suppose, dramatize quite a lot.
Yeah, that's it. Yeah, and this technology works quite well. I can say this is in the new Mercedes E-Class. The Teslas have it. I think Volvo has this technology now as well. So this is technology that's already out in the cars. Okay. It's not legal for you to take you still need to legally be in control of the car, so you can't sit and watch a movie, but the car will be able to drive itself on a highway with you supervising it. So that's kind of where we are now at the moment.
That's still pretty cool. Especially, I don't know how it works for most people, but if you're doing a long drive down to Albany, here, that's going to be a large game changer. That's like a 6 hour drive straight. You got the country roads, which are a bit finicky, but again, if it can work its way around those.
Yeah. And this is also the way these systems are being deployed is that, full autonomy. I think that's anyone's guess when that'll be around, but definitely for the next 2 to 3 years, all the high spec new cars will have some kind of driver assistance feature.
My little Toyota Corolla's never going to keep up. But one thing I would really like to, it would be interesting to see how it copes, because as far as I'm aware, Google don't take into account car parks. They'll say where they are, but they don't manipulate them. So when you get a full autonomous car, or even partially, manipulating it around a car park which is subject to environmental change continuously would be an interesting...
Again, I'm not sure about Google, but Tesla, that's one of the areas they've been actively working on, and from what I understand, they've been able to get some good results.
Really?
We're also working on that technology. You've got to keep in mind that the speeds involved here are very low. Any damage that might occur is just a fender bender. You're very unlikely to cause serious harm in those kind of situations.
Yeah.
But you are right in that it's definitely a continuously changing environment that you need to take account of.
So do you have any perceptions on where you think driverless cars, which I've asked before, but also AI will go in the near future, or even do you think it will ever reach the scale of iRobot and be able to stick up to the Hollywood stigmatized like movies that they throw out?
Yeah, that's a good question. I think if it is there, it's probably at least 10 or 20 years away. So, I mean...
That's still pretty close. Like, well, 10, 20 years, yes, it's half a career for an individual maybe.
Yeah.
But that's still, in a lifetime, that's a huge change when you take into account what we had in the 80s and the microwaves.
Yeah.
That back then were a huge revolution, and then now you've got driverless cars being 20 years away.
Yeah, that's definitely true. I mean, all I can say is all the big tech companies are throwing billions and billions of dollars at this technology. Like Google, after my university invented this technology, they just came in and hired everyone. They even started an office in Toronto just so they could hire this one guy who was the original inventor. And they're all getting millions of dollars chucked at them each to work on this technology.
I really wish I chose some kind of software engineering degree, because...
Yeah, I mean, who knows where it's going to go in the future, but currently it is the big topic. And I think, it's definitely got some room to grow. I mean, we can't predict the advances as they come. Like AI, as an entire field, this has been around for 60 years or something, right? Like since people first conceived of it, and there's been a lot of, breakthroughs and then periods where nothing's happened for 10 or 20 years. Mm-hmm. So, I mean... Yeah, I think so. It's never gone in a linear type fashion. It's always been in drips and drabs.
With that field, with that kind of pattern in mind, and this field in itself, are breakthroughs often associated with a team, or are they all do they come down to an individual's achievements?
I think it's a mix of both, really. The teams I've seen, they're quite close-knit as a team, so they work together as a team and think of ideas as a team.
Yeah.
But at the same time, there's a lot of individual, these are all incredibly smart people. I think especially with this AI, everyone's jumping on it now because it's the big new field. But the reality is, I still think there's only maybe 4 or 5 decent research groups in the world. So there's I would say there's really still only a couple hundred people that really make the big breakthroughs and the big advancements, and the rest, everyone else is just...
capitalize on that move, and then they kind of tune out the fine details.
Yeah, so I think, you could easily say all the good research is done by maybe 10 or 20% of people.
Okay.
So I think really it's kind of a combination of both.
Still, with that in mind, I suppose, if any listeners are out there, if you're looking for a field to go into, it sounds like software engineering, AI development, and that kind of applications of pattern recognition seem to be a growing field, especially in this economic climate where there's not a lot of work out there. That seems to be one of the fields that's still got a fairly substantial financial support behind it. Yeah,
it's definitely true. And I mean, that's why I've pretty much changed careers from mining to get into this new field. It's just, this is where the future is.
How did you find the transition? Like, how long did it take you to get new qualified? And did you have any thought process of, should you change field? Should you just kind of stick out with it?
Yeah, it's a very good question. It took me about a year and a half in total to complete my master's degree. And it was a bit of a big step because, I moved halfway around the world to do it. It cost a lot of money. I wasn't earning money, so I mean, financially and personally was definitely a very big step. But I don't know. I think it's just give it a go. If you like it, you like it. And if you don't have to go through with it.
Yep.
I mean, I'm very big on the just give it a go and see how it goes. The reality is with all this technology as well, like there's all these web resources and web courses that you can quite easily teach yourself.
And you kind of get a rough idea whether that's something you would be into. Like if you can't follow through with a web course with interest, you probably shouldn't go to a master's or a degree in it if you can't necessarily hold an interest in it. That could just be a format of the course, I suppose.
But I mean, really, we've also got to qualify, I think, what you're exactly after. I mean, being a Google or a Facebook researcher or something, and between, they're really pushing the fundamental boundary of this technology, right? As most of the work is just grabbing these algorithms and just putting some data in them, right?
Yeah.
So currently, there's all these great pieces of software where someone's already gone in and programmed all the algorithms, and you can literally just put the data in and it'll come with something out. So I think it's important to understand what's happening, but at the same time, you don't need to be able to program it from scratch or, have the same understanding as one of these fundamental researchers, how they work.
So, do you happen to have anything you'd like to finish the show with, a statement, or do you have any advice for anyone, or anything you advocate for that you would like to present?
That's a good question. So, I think, it's an interesting field. And if you're interested in I think it's good to give it a go. I mean, you can very easily read about it on the internet. There's a lot, that's one of the interesting things about this technology is it's not developed behind closed doors. So all of, for example, Google, all their latest research is published for free on the internet. So you can easily see, not the Google search algorithm, but every other algorithm they use, for speech recognition or translation, the complete blueprints of those are on the internet.
Still peer reviewed and all that that comes straight from Google, or is it like an open source without a...
It's open source, yeah.
Okay, that's pretty generous of them.
Yeah, it's very, very interesting, yeah. So, I think if you're interested in, give it a go. Also there's a lot of opportunities around. For me, I'm also quite lucky to be able to work in Germany, for Mercedes. So, have you found the working environment in Germany in comparison to what you did in Australia? It's different. The Germans are very different in the way they work. Yeah. So, do you find the working environment just nicer, or is it just different? It's just still quite up, still goes down. Yeah, I don't think there's anything that's perfect. I would definitely say it's different. But okay. I mean, at the same time, they've been able to accomplish quite a few things in the field of engineering. Yeah, they're pretty well known for their engineering, I must say. Yeah. Awesome. Well, thank you very much for coming on the show. It's been great to have you. Yeah, thanks very much. Yeah, and I suppose we're... So that's it from us today. Thank you very much for joining us once again. I hope you enjoyed the show and learned something. If you did, please rate us and subscribe to us on iTunes. Share us with your friends and family. We're on Twitter and Facebook. Find our website. Check it out. As I said before, it's a good website. Do all the things that really help us. It really encourages us to keep going on with the show and finding out new research that's being conducted in Australia by Australian researchers. If you're new to Vaguely Accurate and this is your first episode, or you've missed a few, please go back and listen to the other episodes. There is no date or chronological order to them. They are just some highlighting showcases of fantastic researchers doing stunning, cutting-edge research. That's all for us. Take care and good day.